In this problem, we're going to look at tangents to a circle again, but in this case, we have a point that is not on the circle, and so we are going to end up with two tangent lines. Let's see how that works. We want to consider the unit circle, so that's a circle centered at the origin with radius 1, and the point 4, 2 not on the circle. There are going to be two tangent lines to the circle through that point 4, 2, and a point P is going to be that point of tangency on the circle. And we want to find the equations of those two tangent lines. So let's see if we can draw a sketch of what that's going to look like. First off, we have a coordinate plane, and we're going to have a point 4, 2 that's not going to be on our circle. And we have a unit circle, which means we have a radius of 1 centered at the origin. And from this point here, we can see that we're going to be able to draw two lines from the point 4, 2 that are going to be tangent to the circle. So let's see if we can draw those two lines approximately. Here's one, and there's the other. And we'll call this point P. Okay, one of the things that we know, of course, is that the line that is tangent to the circle has a slope that is going to be perpendicular to the radius. Okay. So what do we know so far? Well, we know the equation of the circle. Equation of the circle is x squared plus y squared equals 1. And this point P, we can say it has unknown coordinates x, y. So we know the slope of the radius to the point of tangency. Subtracting our coordinates, remember our origin is 0, 0, so we have y minus 0 over x minus 0, or y over x. That means, of course, that the slope of the tangent line is the opposite reciprocal of that, so that's going to be negative x over y. We can also write an equation for the tangent line using this slope. So our equation of our tangent line, here's our point that is on the line, and our slope of our tangent is negative x over y. So remember, our point slope form is y minus y1 equals m times the quantity x minus x1. So using those coordinates, the coordinates 4, 2, and the slope negative x over y, we get y minus 2 equals negative x over y times the quantity x minus 4. That does not look like it's a very useful form. We can make it a little bit nicer by multiplying both sides of the equation by y, giving us y squared minus 2y equals negative x squared plus 4x. So this is our equation of our tangent line, and the tangent line needs to meet the circle at our point xy. So I'm looking for the intersection of the circle and the line. I'm looking for those points x and y. So I can solve this system of equations and see what happens with this. Let's see if we can get them in the same form. Notice this one has x squared plus y squared on one side of the equation and the constant on the other. So let's see if I can get this equation with x squared and y squared on one side and everything else on the other side. We have adding x squared. So we have x squared plus y squared equals 2y plus 4x. And we also have x squared plus y squared equals 1. Now that kind of looks nice because I can just replace the x squared plus y squared with 1 here, but I still have both variables y and x over here. So let's take our equation of that circle and let's solve it for one of the variables. Let's solve it for x. Taking this and solving it for x, we're going to have x squared equals 1 minus y squared, or x is equal to the positive or negative square root of 1 minus y squared. Okay, so as I'm looking at different points, I know up here x would be negative and down here x would be positive. So let's go ahead and let's choose the positive one just because it's much easier working with the positive. And let's find out what our x coordinate of this point is first. So x equals the square root of 1 minus y squared. Okay, so let's see what we can do. First off, I think we found out that if we actually subtract these two equations, these two terms go away, and we end up with 0 equals 2y plus 4x minus 1. Subtracting the equations. Okay? And now substituting in for x, we get 0 equals 2y plus 4 times the square root of 1 minus x squared minus 1. So here we have a radical equation. In order to solve the radical equation, we need to get the radical on one side. So let's go ahead and subtract 2y and add 1 to both sides. And now we want to undo the root here, so let's go ahead and we're going to square both sides of this equation. So this is a binomial squared. It gives us 4y squared minus 4y plus 1. And on the right side, it's just a single monomial. The 4 squared is our coefficient, 16, and root 1 minus y squared is 1 minus y squared. Okay, so it's a quadratic equation now. So let's go ahead then and get it in the correct form with one side equal to 0. So let's start by distributing the 16. Okay. Get one side equal to 0. So adding 16y squared gives us 20y squared and minus 4y. And subtracting 16 gives us minus 15, and that's equal to 0. Okay, we can put this into the quadratic formula. I'm not going to do all the arithmetic on that, but when we put it into our quadratic equation, we get y is equal to 4 plus or minus the square root of 4 squared minus 4 times 20 times negative 15, all divided by 2a, which is going to be 40. And when we use those and we put those into our calculator, we've got two possibilities for y. One possibility for y is 0.972, and the other possibility for y is negative 0.772. Okay, when y is positive, if we go back and look at our original drawing here, when y is positive, x is going to be negative. So let's go back here to our equation, solve for x, and let's choose the negative possibility. So when we do that, we get x is equal to negative 0.236. When y is positive, we're on this part of the equation, or this part of the circle. Our x coordinate is negative, and when our y is negative, our x is going to be positive. So let's go back and use this equation. So when y is equal to negative 0.772, x is going to be the positive square root of 1 minus negative 0.772 squared. And when we do that, we get x equal to 0.636. So these are our 2 points of tangency on our circle. So we now have the coordinates x and y, where our point of tangency here and here. Now we want to find the equations of the two tangent lines, which means we need to find the slope. So our slope of our tangent line is going to be negative x over y. So in each case here, let's do our slope by doing negative x over y. When we do that, on this one, we get a slope of positive 0.243. And on our second possibility, doing negative x over y, we get a slope of 0.824. Negative 0.636 divided by negative 0.772. Okay, so now we can write our equations of our tangent lines. Again, we can write it in either point-slope form or slope-intercept form. For point-slope form, let's go back and use the point that we originally were given. We know that there was our point on the tangent line was the 0.42. So our first line is y minus 2 equals our slope of 0.243 times x minus 4. And we can convert that to slope-intercept form if we choose. Our second line, again using our 0.42, is going to be y minus 2 equals our slope of 0.824 times x minus 4. And that's how we find the equations of two tangent lines to a circle from a point outside the circle. Let's review those steps. Those steps, we had to find the equation of the circle first. We identified the slope of the radius as being y over x, y minus 0 over x minus 0. The slope of the tangent line was the opposite reciprocal, so that allowed us to write the equation of our tangent line. Then we had a system of equations that we needed to solve, and we used a combination of elimination and substitution to do that. When we eliminated one of the variables, we had an equation in y. It was a radical equation, so we had to solve that radical equation using the quadratic formula, and then we went back, substituted back, found our values for x after finding y, and finally used our original 0.42 to write the equation of the tangent line.